I'm Anil Kumar. Welcome to my series on equivalent algebraic expressions. We'll discuss how to add and subtract rational expressions in this particular video. So these are the four examples which we'll cover, and we'll also understand the basic concepts. Rational expressions are very similar to rational numbers, and therefore the very first example which I have taken is to see how do we add 2 over 45 plus 7 over 30. And then we'll see how we can apply the same concept to add the rational functions. So let's begin with the very first one, which is 2 over 45, and we want to add 7 over 30. Now these are rational numbers where we have ratio of integers, right? One integer over the other integer, and we need to add them. So the concept here is basically to make common denominator, right? So the first step which we look into in such cases is to find the lowest common denominator, right? So we are looking for lowest common denominator. How do we figure this out? Well, we can look into the factors of 45 and 30. Now 45 can be written as 5 times 9, and 9 can be further factored, so we get the factors of 3 and 3, right? So for 45 we have these three factors. As far as 30 is concerned, we could write this as 3 times 10, and 10 could be factored as 2 times 5. Correct? So that means that 45 can be written as 5 times 3, which is 3 squared, and 30 can be written as 3 times 2 times 5. Now from these, the lowest common denominator will be, we have 1 5, right? As far as 3 is concerned, we have 2 3s, 3 squared, and then 2. So when you multiply this, we get 5 times 2 as 10, and 10 times 9 as 90, correct? So we get a factor, common factor, which is also the lowest common factor, is multiple, I should say, not factor, lowest common multiple as 90, right? Now, we also say that should be our lowest common denominator. So we have to make both the denominators as 90. How can you do that? Well, we have 2 over 45. We need to multiply this by 2 and also divide it by 2, correct? So to make it 90, which is our lowest common denominator, we have to multiply and divide by 2. Similarly, for 7 over 30, we need to multiply and divide by 3, right? So that gives you as equal to 4 over 90 plus 3 times 7, which is 21 over 90. Now, when we have a common denominator, we can add the numerators. So we say it is 4 plus 21 over 90, and so the result is 25 over 90. Now, 25 over 90 can also be simplified, right? So we can divide both by 5 and simplify the result. So if I divide by 5, what do I get? We get 5 in the numerator, and dividing 90 by 5 times 1, 48, right? So we get our answer as basically 5 over 18. So as you see, the steps being followed are that we have to somehow get the lowest common denominator. Once we get it, then both the rational numbers in this case are written with the same denominator, and the numerators are then added. And if possible, then we do simplify it and write down our answer, right? So in this case, we get our answer as 5 over 18. So I hope the steps are absolutely clear. We are now going to follow these steps in our examples and understand how do we add and subtract rational expressions. So I hope this concept is clear, right? Now we are going to apply the strategy learned in this particular case. We'll simplify and state restrictions. 1 over 2x squared plus 2 over xy minus 3 over 5y squared. Well, for any rational expression, the denominator cannot be 0. So the restrictions here are that x is not equal to 0 and also y is not equal to 0. So these are the two restrictions for us. So first thing, let us state the restrictions. Now, let's see. What is we need to add and subtract these. Let me rewrite them. We have 1 over 2x squared plus 2 over xy minus 3 over 5y squared. Now, as far as the lowest common denominator is concerned, we have x squared, we have y and y squared. So the lowest common denominator in this case is going to be what? 2 and 5, right? They get multiplied. So lowest common denominator is 10x squared y squared. Correct? So that becomes the lowest common denominator. Now, to make each term with this lowest common denominator, what should we do? We have to multiply both numerator and denominator by the same thing. So we have here 1 over 2x squared, and to make it 10, we have to multiply by 5 and divide by 5. We need y squared also, so we'll multiply and divide by y squared, right? Same thing is done on the other two terms also. So we have 2, and here we have x times y. In this particular case, to get 10, we have to multiply and divide by 10, and as far as the variables are concerned, xy, correct? The third one, here is 3 over 5y squared. To get 10 in the denominator, we have to multiply and divide by the number 2, and x squared, y squared, x squared is missing, so we'll multiply and divide by x squared. So when you do that, you do get common denominator. And now the common denominator for us is 10x squared y squared, correct? Numerator gives us 5y squared, and that gives us plus 20xy, and here we get 3 times 2 as 6x squared, correct? So that becomes our numerator, and this is the result of adding and subtracting these rational functions, correct? This cannot be further simplified, and therefore we are going to leave it right there. So I hope that makes sense. And the restrictions, as I mentioned earlier, here x is not equal to 0 and y is also not equal to 0, since division by 0 is not permitted, correct? Now let me also write a general rule here. So if we have a rational function of the form of px over qx, and we are adding or subtracting some other rational function from it, let's say rx over sx, then in that case, in general, we could write it kind of like this. We could multiply the denominators if they don't have anything in common, right? And then we could write this as px times sx plus or minus rx times qx, right? So that in general is to be done. And note here that qx and sx should not be equal to 0, and that leads to restrictions. Is that clear? So that is a general rule. Now we are going to follow these steps to solve the next two examples. The question here now is 2 over 5mn minus 3n plus m square over 2m cube plus 3. So let me rewrite this. We have 2 over 5mn minus 3n plus m square over 2m cube plus 3. Now see, what is the common denominator here? So let's begin with the numbers 5 and 2. 10. So 10, right? So then we get 10. M cube, right? So that is 1. And as far as n is concerned, we have n. So that becomes our common denominator. Perfect. Now, to get this, what should I multiply the first term with? We already have 5 times mn. So I have to multiply this number by what? To get 10, I have to multiply this number by 2, right? Because 5 is already there. So by 2. And m square, right? So m square. We have n that will result into the same denominator, correct? In the second case, we have 2m cube. Now that means we need 5 times n. So we'll multiply 5 times n with 3n plus m square. Is that clear to you, right? Plus 3 times, here the denominator is 1. So we'll multiply by all of them, which is 10 m cube n. Does make sense to you, right? And now let's open this bracket. So we get 4m square minus 5 times 3, 15n square. Change the sign. 5m square n, and then here we get plus 30 m cube n, right, over 10 m cube n. Is that correct? So that is how we could get our result. Well, if you want, you could arrange them in an order with highest degree of m first, right? So you could write this as 30 m cube n, and here we have minus 5m square n. You could take m common anyway, plus 4m square minus 15n square over 10 m cube n. So that will be the simplified form. Now let us also add the restrictions, correct? So what are the restrictions here? Denominator cannot be 0, correct? So that gives us restrictions as m is not equal to 0 and n is not equal to 0. Perfect. So that is how we are going to do it. Now here is the last example, slightly more complicated. I would like you to do this and then you can take up unit test on this particular chapter. I hope that will make sense. Once you have done, then you check with my solution. We need to simplify and state restrictions for x plus 5 over x square minus 2x minus 15 plus 5x minus 2 over x square minus 5x. Now the first step is to find the lowest common denominator. So let's factor both of them and then see what could be the lowest common denominator, right? So we could write this as x plus 5 over x square minus 2x minus 15. That means we are looking for a product of 15 and sum of minus 2. So 3 times 5 can work. Negative means we have to use x minus 5 times x plus 3. So that will give us negative 2x, right? Plus 5x minus 2. So the numerator 5x minus 2, denominator x square minus 5x. X is common, so we'll take x common and we get x minus 5 in our denominator, right? So the first step normally will be to factor. And now we'll find the lowest common denominator, right? Now in this case, the lowest common denominator is, so we have these factors. Well, x is alone, so x1, and then we have x minus 5, and we also have x plus 3. So that will become the lowest common denominator. Now in the first term, in the denominator, x is missing. So we'll multiply the numerator by x. So we get x times x plus 5, right? Plus. In the second term, the factor x plus 3 is missing. So we are going to multiply that by x plus 3. Is that clear? Perfect. Now, whenever you do this operation, we like to keep the denominator in the factored form. I like you not to ever expand the denominator, right? But you need to expand and simplify the numerator. So we'll keep the denominator as such. Numerator, let's expand it. We get x squared plus 5x plus 5x squared minus 2x plus 15x minus 6, right? Now that is what we get. We can now combine the like terms, okay? So let's write this as combining the like terms. The denominator here is x times x minus 5 times x plus 3. As far as x squared is concerned, we get 6x squared. 5x minus, well, 5 plus 15 is 20. Take away 2 is plus 18x. The number is minus 6. So that is what we get, right? So if you want, you can factor the numerator taking 6 common, right? So we could write this as 6 common. We get x squared plus 3x minus 1, and the denominator is x times x minus 5 times x plus 3, correct? So that is the simplified form. Now, important part here is also to write the restrictions. So the restrictions is that the denominator cannot be 0. So we get x is not equal to 0. Then this factor will be 0 for 5, and this will be 0 for minus 3. So these 3 becomes the restrictions. And that is the simplified form. Is that correct? So that is how we have to do addition and subtraction of rational functions. So I hope with this, the basic concept is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.